Good morning and welcome to today's class. Today's class is a continuation of our previous classes on quadratic equations. At the last class, we were looking at how to express quadratic equations as perfect squares. And in that class, I told you that we have two steps to determine if a quadratic expression is a perfect square or not. And I said that the first term and the last term must be perfect squares, as well as the second or middle term must be twice the product of the square root of the other two terms. I equally gave you few examples on how to determine if an expression, a quadratic expression, is a perfect square or not. I also left the class with an assignment where you are asked to determine whether each of these is a perfect square. Which of these is a perfect square? So I believe you must have done that, and if that has been done, let's look at the solution and you can compare it with yours to know if you are right or wrong and take the necessary correction. Now the question says, which of the following are perfect squares? We have A that says u squared minus 14u plus 49. And what you should do in this case is to take these two conditions which I gave you, to compare each of them and see if they met the two conditions necessary for a quadratic expression to be said to be a perfect square. So we are going to look at them and see if if the first and the last terms are said to be perfect squares, and if the middle term is plus or minus twice the product of the square roots of the first and second term. So let's look at question number 1a. If you look at the first term, is u squared a perfect square? Yes. Is 49 a perfect square? Yes. And minus 14u, is it twice the product of the square roots of these two? Yes. But in order for us to get it right, let's do it this way. I'll take this to be u squared minus 2 times 7u plus 7 squared. All you need to do is to see how you can simplify each of these questions or express each of them as x squared plus or minus 2xy plus y squared. Okay, so once this criteria is being met, then you can then conclude that such expression is a perfect square. If it does not conform with this, then it is not a perfect square. So I have to write u squared minus 14u plus 49 in this form: x squared plus or minus 2xy plus y squared. And when you look at it, you discover that 7 is equal to the last term and u is this. So once that is done, you then conclude that such is a perfect square. So question number 1 is a perfect square. 2, can we express 6x squared plus 13x plus 6 as this? Let's see. This will be equal to 6 is not a perfect square, as well as this. So long as one of them violates the rules, such an expression is not a perfect square. So this is a perfect square. You can write it perfect square, whichever way you want to denote it. This is not a perfect square. And why is it not a perfect square? 6 is not a perfect square, which is a condition that 6 and 6x squared must be perfect squares. So so long as this is not a perfect square, then it is not such an expression is not a perfect square. Even if this is twice the product of the first square root of the product of the first term and the last term, this is not a perfect square. C, we have 2b squared plus 2b minus 7. We have so many reasons why this is not a perfect square. This ought not to be a negative. 7 is not a perfect square. Likewise, 2 is not a perfect square. So this is not a perfect square. So we said this is not a perfect square. D, u squared plus 2vu plus v squared. This is a perfect square, simply because the first term and the last term are said to be perfect squares, while the middle term is said to be twice the product of the square root of the first and the last term. U squared and v squared are said to be perfect squares because the square root of v squared is v, as well as the square root of u squared is u. So both are said to be perfect squares. So that is that with the assignments I gave you at the previous class. So you can compare your answers with what I have and take the necessary correction. Don't forget to like our videos as well as to subscribe if you have not done that. We equally encourage you to share with your friends. In today's class, we shall be looking at more exercises on perfect squares. In this particular series, we shall take the following exercises. That which of the following quadratic expressions are perfect squares? Factorize where necessary. That is to say, we will first of all check if they are perfect squares. If they are, then we have to factorize. So, just as a reminder, this says, number 1 says a squared plus 2a plus 1. Is it a perfect square? If it is a perfect square, then we factorize. Remember, we said a perfect square, a quadratic expression is said to be a perfect square if it can be expressed as this: x squared plus or minus 2xy plus y squared. And if it's possible, then this can be factorized to be either x plus y all squared or x minus y all squared for a negative. So let's first of all look. Check if this is a perfect square. Yes, because this can be expressed as a squared plus 2 times 1 times a plus 1 squared, because 1 squared is still said to be 1. Alright, so if this is that, let me write it as 2a plus 2 into bracket 1a plus 1 squared. Then this can be factorized when you compare it with this as a plus 1 all squared. As simple as that. Question 2 says x squared minus 12x plus 36. Let's compare if this can be expressed in that form. This is said to be x squared minus, divide the constant term by 2. This gives us 2 into bracket. You'll be left with 6x plus 6 squared. Now this is said to be a perfect square because the constant term in that bracket is same with 6, which means the middle term is twice the product of the square root of the first term and the last term. So this can be factorized as x, because this is minus the last term, which is 6, or squared. As simple as that. So this is how you can factorize a quadratic expression that is a perfect square. 3. Can this be expressed? No. In as much as y squared is a perfect square, 27 is not a perfect square. So invariably, this may likely not be twice the product of the first term and the last term. So this is not a perfect square. So it's not a perfect square, and we cannot simplify or we cannot factorize it. That brings us to the end of today's class. In today's class, we have been able to solve more exercises on perfect squares. See you in our next class. Kindly like our videos as you watch. Also subscribe if you've not done that, and share to your friends and families so that they can also benefit from this project. See you in our next class. In our next class, we shall be looking at how to make a quadratic expression a perfect square. For example, I just said this is not a perfect square. So what do you do to make it a perfect square? That we shall learn in our next class. See you and have a nice day.